Right now, there are vehicles sitting in private garages, behind locked gates, and buried in regulatory footnotes that you are not legally allowed to drive on public roads. Not because they're broken, not because they're unsafe by the standards of their era, because governments decided these machines were too dangerous, too uncontrollable, or too far outside the lines to exist alongside modern traffic. And here's the part that should bother you. Some of these cars contain engineering so advanced, so mechanically brilliant, that the regulations weren't about protecting people. They were about controlling what people could access. Most enthusiasts have no idea these vehicles exist, let alone that owning one puts you in possession of something the system actively tried to erase. These are 10 ancient cars that are now banned, and the mechanical reasons behind each ban tell you more about real automotive engineering than any showroom ever will. The first vehicle that demands your attention is the 1966 Hindustan Ambassador Mark III. Now, most Western car enthusiasts have never even heard of this car, and that's exactly the point. The Ambassador was India's dominant automobile for decades. Based on the Morris Oxford series III from 1956, it was manufactured with almost no structural changes well into the 2000s. The body was heavy-gauge steel, the frame was a traditional ladder type with boxed cross members, and the suspension was built to survive roads that would destroy most European sedans in a single monsoon season. Let me tell you what I mean by that. The front suspension used double wishbones with coil springs and a stabilizer bar, while the rear ran a live axle on semi-elliptic leaf springs. Nothing fancy, nothing fragile. Every bushing, every joint, every spring perch was over-engineered by a factor that modern cost-cutting engineers would find offensive. The mechanical simplicity of this car was its greatest weapon. You could rebuild the entire drivetrain with hand tools in a village with no electricity. The engine, a 1.5-liter BMC B-Series in early versions, later swapped to an Isuzu-sourced diesel that made about 37 horsepower, but generated enough low-end torque to pull the car through axle-deep mud without complaint, was virtually indestructible. The cooling system was designed for ambient temperatures exceeding 115 degrees Fahrenheit. The electrical system was so basic that a failed component meant 30 minutes of diagnosis, not a trip to a dealer with a diagnostic computer. But here's where the ban comes in. India's own government, under tightening emissions and safety standards from the National Green Tribunal, effectively banned the production and new registration of the Ambassador after 2014. Vehicles older than 15 years in cities like Delhi face outright prohibition from the road under anti-pollution directives. So a car that was literally designed to be the backbone of a nation's transportation is now illegal to drive in the capital city, where it once ruled every lane and alley. The irony is brutal. The Ambassador's mechanical reliability, its pushrod simplicity, its thick-gauge steel body, its rebuildable everything, is exactly what modern disposable engineering has abandoned. If you find one in good condition outside India's metro ban zones, you're holding a piece of mechanical philosophy that most modern cars can't touch. And because the market hasn't caught on yet, they're still affordable. That won't last. Now let me take you to something European. The Citroën 2 CV, the Deux Chevaux, is one of the most misunderstood vehicles ever manufactured. Built from 1948 to 1990, this car was designed with a single purpose: get French farmers across plowed fields with a basket of eggs on the seat without breaking a single one. That's not a joke. That was literally part of the original design brief from Pierre-Jules Boulanger. He told his engineers the car must be able to cross a field, and the suspension must be so compliant that a basket of eggs wouldn't crack. They delivered. The suspension system on the 2CV is interconnected, front to rear through horizontal coil springs housed in cylinders running along each side of the chassis. When the front wheel hits a bump, it compresses its spring, which pushes force through the cylinder to the rear, effectively preloading the rear suspension for the same bump. The car leans into corners like a sailboat in a cross breeze, and it absorbs impacts that would crack the spine of a modern compact crossover. The air-cooled flat-twin engine, 602cc and later models, ran a single carburetor, produced about 29 horsepower, and could be rebuilt on a kitchen table by someone with moderate mechanical aptitude. I've personally seen a 2CV engine torn down to the bare case and reassembled in under 4 hours. The body panels were bolt-on, interchangeable left to right, and designed to be replaced by a farmer with basic hand tools and a Saturday afternoon. So why is it banned? In several countries, the 2CV fails to meet modern crash safety and emissions requirements for new registrations. In parts of the European Union, low-emission zones have effectively made it illegal to drive a 2CV in city centers across Paris, London, Brussels, Amsterdam, and an expanding list of urban areas, the very cities where it once defined the streets. The engineering lesson here is in the suspension geometry and the weight-to-function ratio. At roughly 1,100 pounds, the 2CV did more with less than almost any vehicle in history. If you understand what that interconnected suspension can teach you about load transfer, chassis dynamics, and ride quality without electronic damping, you're ahead of 90% of people who call themselves car enthusiasts. These are principles that cost nothing to understand and everything to ignore. If you're finding value in this kind of breakdown, engineering over hype, mechanical truth over auction noise, consider subscribing. This channel is built for people who want to understand what makes a machine worth owning, not just worth posting about. The next car on this list is one that was banned before most people ever got to touch it. The Bricklin SV-1, manufactured in 1974 and 1975 in St. John, New Brunswick, Canada. SV stood for Safety Vehicle, and Malcolm Bricklin designed this car around one obsessive idea: build the safest sports car on the planet. It had integrated 5-mile-per-hour bumpers that were part of the body structure rather than bolt-on afterthoughts. The perimeter frame was steel, heavy and robust, while the body was constructed from fiberglass bonded to acrylic, creating a colored-through panel that didn't need paint and wouldn't show scratches down to bare material. The gullwing doors were powered by hydraulic systems fed from an engine-driven pump. There was no cigarette lighter, no ashtray. Bricklin believed smoking in a moving vehicle was a safety hazard and refused to include them. Under the hood, early cars received AMC's 360 cubic inch V8, while later production switched to Ford's 351 Windsor. Both were serious, proven American iron with deep parts support and straightforward serviceability. The AMC 360 in particular was a torque-rich engine with excellent low RPM manners, kind of power plant that a mechanic could keep alive indefinitely with basic maintenance. The problem was execution. The car was too heavy for its chassis rigidity. The steel frame flexed under the weight of the body. The gullwing doors frequently trapped occupants when the hydraulic pressure dropped, and the acrylic body panels cracked in Canadian winter temperatures. The New Brunswick provincial government, which had invested heavily in the factory, pulled funding after massive cost overruns. Production stopped at fewer than 3,000 units, and the Bricklin became nearly impossible to register in several Canadian provinces due to its failure to meet updated safety inspection standards. The very car built to be the safest on the road became too unsafe to be allowed on it. But here's what people miss. The engineering intent of the SV-1 was decades ahead. Colored through composite body panels, integrated energy-absorbing bumper structures, occupant-first design philosophy. This was the thinking. That wouldn't become mainstream until the late 1990s, and some of it, like the colored-through body material, is still ahead of what most manufacturers offer. The chassis design was flawed in execution, not in concept. If you can find an SV-1 with a solid frame, the AMC or Ford V8 under the hood is a restoration platform that most people wouldn't think to look at twice. That's their mistake. Let's cross the ocean again. The Reliant Robin, and yes, I can already hear some of you laughing. The three-wheeled British Icon, manufactured from 1973 to 2001, was classified not as a car but as a motorcycle in the United Kingdom. This classification meant you could drive it on a motorcycle license. It was taxed at a lower rate and it sipped fuel like a moped, but the single front wheel created a center of gravity problem that made the Robin infamous for tipping over in corners. It became a global punchline, especially after a certain television program decided to lean into the comedy at the expense of the engineering. But mechanically, the Reliant Robin is far more interesting than the jokes suggest. The body was fiberglass, a full fiberglass monocoque, which made it remarkably light at around 990 pounds. This wasn't a fiberglass shell over a steel frame. This was a structural fiberglass body that carried the loads. The 850cc overhead valve engine was an all-aluminum four-cylinder unit designed and cast by Reliant themselves, not borrowed from another manufacturer. It was efficient, surprisingly smooth, and durable enough to run well past 100,000 miles with basic maintenance. The gearbox was a 4-speed manual with synchromesh on all forward gears, and the whole drivetrain was designed as an integrated unit, where every component was sized to work with every other component. No over-engineering, no waste. After a series of regulatory changes in the UK and EU, the Robin no longer meets modern vehicle classification, emissions, or safety standards. For new registration, existing ones are increasingly squeezed out of urban areas by emission zones and insurance restrictions. What's been banned isn't a joke. It's a masterclass in lightweight construction and purpose-built engineering. Reliant figured out fiberglass monocoque manufacturing at a production scale decades before Lotus made it fashionable in the Elan. That body technology, that weight discipline, that philosophy of building exactly enough car for the job, those are principles that the supercar industry would later spend hundreds of millions trying to replicate with carbon fiber. The fifth vehicle is something altogether more menacing and more complicated. The Kübelwagen, the Volkswagen Type 82, was Nazi Germany's light military transport, designed by Ferdinand Porsche and manufactured from 1940 to 1945. It was based on the Volkswagen Beetle platform, using a modified version of the air-cooled flat-4 engine, initially 985 cc, later 1,131 cc, and a rear-mounted transaxle. The body was flat-paneled pressed steel, designed to be stamped out quickly on simple tooling and repaired in the field. With minimal equipment, a soldier with a hammer and welding torch could fix combat damage that would total a modern unibody vehicle. The Kübelwagen had something most people don't know about: portal gear hubs at the rear axle. These reduction gears at each wheel hub effectively raised the entire body and chassis relative to the axle center line, giving the vehicle almost 12 inches of ground clearance on a platform that weighed barely over 16 pounds. The rear-engine weight bias, which would be considered a handling liability in a sports car, actually gave the Kübelwagen surprisingly good traction in sand and soft terrain. Allied forces who captured Kübelwagens in North Africa often preferred them to their own jeeps for desert operations. Now, the Kübelwagen isn't banned because of its mechanical shortcomings. It's banned, or heavily restricted, in several European countries because of its direct Nazi military provenance. German law restricts the public display of certain Nazi-era military symbols and equipment, while private ownership of a Kübelwagen is legal. Taking an original, military-marked Type 82 onto public roads in Germany or Austria is legally complicated at best and prosecutable at worst, depending on the specific markings and context. Several other European nations have similar restrictions. This creates an unusual situation where the mechanical platform, essentially a Beetle chassis with different bodywork, is completely legal and widely celebrated. But this specific vehicle in its original military configuration exists in a legal gray zone that grows more restrictive every decade. The engineering underneath is pure Porsche. The portal reduction gears, the torsion bar independent suspension, the air-cooled simplicity, the principle of maximum capability from minimum complexity. These are the same ideas that made the 356 and the 911 into legends. You just can't drive this particular expression of that genius down a German highway. Here's something a lot of people in this community overlook. If you've ever wanted to understand why certain engines last forever while others eat themselves alive, the vehicles on this list are a mechanical education. Drop a comment below and tell me which of these banned cars surprised you the most. I read every single one. Moving on. The Trabant 601 is a car that an entire generation of Eastern Europeans grew up with, waited years to purchase, and then watched become illegal almost overnight. Manufactured in the Sachsenring factory in Zwickau, East Germany, from 1964 to 1990, the Trabant was powered by a 600cc two-stroke inline twin engine that produced roughly 26 horsepower and consumed a premixed fuel-oil combination. That left a blue haze behind every vehicle like a mechanical signature. But the real innovation was the body. The Trabant's exterior panels were made from Duraplast, a thermoset composite of recycled cotton fibers from the Soviet Union's textile industry, mixed with phenol resin, and pressed under heat and pressure over a stamped steel skeleton. Duraplast didn't rust. It was incredibly light. Each panel weighed a fraction of an equivalent steel panel. It could absorb minor parking impacts without permanent deformation, and it was born entirely from necessity. East Germany couldn't source enough sheet steel for its automotive production, so engineers invented a new material from industrial waste. That's not compromise engineering. That's brilliant engineering under impossible constraints. After German reunification in 1990, the Trabant was systematically pushed off Western roads. It couldn't pass West German TÜV emissions testing. The two-stroke engine produced hydrocarbon and particulate emissions that were orders of magnitude beyond acceptable levels. It couldn't meet crash safety standards designed for cars twice its weight. Insurance became prohibitively expensive. Scrappage programs actively incentivized owners to destroy them. In many German cities today, you simply cannot register a Trabant for daily road use. They've been effectively banned through layered regulation rather than a single law, but the result is identical. A vehicle that mobilized an entire nation for 3 decades is now a museum piece. What's lost when the Trabant disappears from the road isn't just nostalgia. It's knowledge. That Duraplast body technology was an early form of composite construction that modern engineers are only now revisiting with natural fiber composites in the name of sustainability. The two-stroke engine, for all its pollution, was mechanically simple to a degree that borders on philosophical. 2 moving parts in the bottom end, crankshaft and connecting rods, that's the entire rotating assembly. You could diagnose every possible failure mode with your ears and fix it with a wrench, a screwdriver, in 15 minutes. That kind of direct mechanical literacy, the ability to hear a problem, understand its cause, and fix it immediately, is vanishing from the world. Trabant was one of its last living classrooms, and we let it get crushed. The 7th vehicle takes us to Japan, and it's one of the most remarkable packages in automotive history. The AutoZam, a Z-1, built by Mazda under its AutoZam dealer network from January 1992 to October 1993. Read this specification and let it sink in. Mid-engine, rear-wheel drive, gull-wing door K car. A vehicle that weighs 1,580 pounds, measures 129 inches long. That's shorter than most modern SUV hoods, and stands just 45 inches tall. The engine is a Suzuki F6A, a 657cc turbocharged 3-cylinder with an intercooler, making 63 horsepower at 650 RPM. In a car this light, That translates to a power-to-weight ratio of approximately 25 pounds per horsepower, which puts it in the same neighborhood as vehicles costing 50 times as much. The chassis is a steel monocoque with body panels made entirely from fiber-reinforced plastic, keeping unsprung weight to a minimum and allowing the 63 horsepower engine to feel genuinely quick. The suspension is fully independent. MacPherson struts up front and a strut-type arrangement at the rear, with stabilizer bars at both ends. The steering is unassisted rack and pinion, which at this weight gives you communication from the front tires that modern electric power steering systems actively filter out. You feel every pebble. You feel the tire compound loading and unloading through corners. It's the kind of feedback that driving instructors spend hours trying to teach people to recognize. And the Z-1 hands it to you for free. Only 4392 were ever built. The Z-1 was never sold outside Japan, and importing one to the United States was illegal until the 25-year federal exemption made 1992 models eligible around 2017. But in many other countries, including large parts of Europe, Australia before certain exemptions, and most of South America, the Z-1 remains effectively banned because it cannot meet frontal crash standards, side impact requirements, or pedestrian safety regulations. The car is simply too small, too light, and too devoid of modern safety infrastructure to pass any modern type approval process. And yet the engineering philosophy inside it is the exact same philosophy that defines the modern hypercar. Mid-engine for balance, composite materials for weight savings, turbocharging for efficiency, short wheelbase for agility. Consider this. The turbo lag on the F6A engine kicks in around 4,000 RPM, and then the car comes alive in a way that feels genuinely dangerous, given the lack of any electronic safety net. There's no traction control, no stability management, no ABS. Just you, a turbocharged three-cylinder screaming behind your head, and the laws of physics negotiated entirely through your hands and feet. Mazda built the philosophical blueprint for the modern performance car in 1992, priced it for everyday buyers, and wrapped it in a package that most regulators now refuse to acknowledge as a legitimate vehicle. The few that make it into private collections outside Japan are appreciating rapidly, precisely because the regulatory walls around them get higher every year. What's banned tends to become priceless. Let's talk about the Lancia Stratos HF Strato, the road-going homologation special of one of the most dominant rally cars ever built. Produced from 1973 to 1978 in Turin, Italy, only about 492 units were manufactured, just barely enough to meet the FIA's homologation requirements. Part of the Stratos was a Ferrari Dyno V6, a 2,418cc dual overhead cam unit with 3 Weber carburetors, producing around 190 horsepower in street trim and significantly more in rally specification. That engine sat transversely behind the driver, mounted to a 5-speed manual gearbox. The chassis was an incredibly compact steel monocoque designed by Gian Paolo Dall'Ora, a name that should make any serious engineer sit up straight. The fiberglass body was designed by Burton with Marcello Gandini penning the shape, and the entire front and rear body sections tilted forward and backward respectively for complete mechanical access. The wheelbase was just 85.8 inches. For context, a modern Toyota Yaris has a longer wheelbase. This meant the Stratos could change direction with a violence that shocked even experienced rally drivers. It won the World Rally Championship 3 consecutive years, from 1974 to 1976, dominating on surfaces ranging from Monte Carlo ice to African gravel. In several jurisdictions today, the Stratos faces effective bans. It cannot meet modern emissions requirements, no catalytic converter, open carburetors, and a Ferrari V6 that was never designed with environmental concerns in mind. It has no airbags, no crumple zones, no anti-lock brakes, and no collapsible steering column. The driving position puts the base of your spine approximately 4 inches from the rear axle line. In many European countries, the combination of these factors makes it a regulatory impossibility for new registration, and even existing registrations face growing restrictions from low-emission urban zones. What most people don't understand about the Stratos is the polar moment of inertia. With the engine, gearbox, driver, and fuel all concentrated within the wheelbase, and a wheelbase this short, the car's rotational mass was concentrated so tightly around its center point that directional changes happened faster than most drivers' reflexes could process. The steering wasn't just responsive, it was precognitive. You thought about turning, and the car had already begun. Modern mid-engine cars with 200-inch wheelbases and sophisticated electronic stability systems chase this feeling with billions in development budgets. Dallara and Gandini achieved it with 1970 steel, a borrowed Ferrari engine, and a wheelbase shorter than a golf cart. If you ever get the chance to sit in a Stratos, and I mean sit, not just look at one behind a rope, you'll understand instantly why regulators looked at it and said absolutely not. It's not just a car. It's a sensory argument against every compromise modern automotive engineering has made in the name of safety, comfort, and compliance. And it's an argument you're no longer legally allowed to experience on a public road in most of the world. The ninth vehicle is the AC Cobra 427. Specifically, the original Shelby-era cars built between 1965 and 1967. Not the replicas, not the continuation series, not the kit cars. The originals, of which fewer than 350 were completed. These were, at their core, a lightweight British AC Ace Roadster body mounted on a 4-inch diameter tubular steel chassis, with Ford's monstrous 427 cubic-inch FE side-oiler Vate stuffed into the front. The result was approximately 425 horsepower in a car weighing around 2,350 pounds. Do the math on that power-to-weight ratio. It's terrifying. The rear suspension was a live Dana 44 axle located by trailing arms and a transverse leaf spring, a setup that engineers understood was a compromise even at the time. Under hard acceleration, the rear axle would wind up, loading the right rear tire and unloading the left. Under hard braking, the nose would dive and the rear would become light enough to step sideways with almost no provocation. At speed, crosswinds would push the lightweight body around on the highway like a sail. Carroll Shelby himself, a man not known for restraint, called the 427 Cobra the most dangerous car I ever built. The original 427 Cobras were never subjected to modern crash testing, never emissions certified for contemporary standards, and in many countries today, they cannot be legally registered for road use without exemptions that are increasingly difficult to obtain. The UK's individual vehicle approval process, various EU type approval regulations, and even certain US state-level emissions laws have created a patchwork of jurisdictions where driving an original 427 Cobra on public roads is either outright illegal or requires modifications so extensive that the car ceases to be original. The mechanical story of the Cobra 427 is really a cautionary tale about the limits of chassis engineering. The tubular frame was designed for a gentle Bristol 6-cylinder engine. Shelby crammed a 7-liter racing Vate into it with wider fenders but fundamentally minimal structural reinforcement. The car was faster than almost anything on the road in 1965, and less controllable than almost anything on the road in 1965. Every modern supercar engineer has studied the Cobra, not just for what it achieved, but for what it taught about the catastrophic consequences of powertrain outrunning chassis. The Cobra proved, at the cost of real human lives, that raw horsepower without structural discipline is a weapon, not a tool. That lesson shaped the development of everything from the GT40 that followed it to the modern Ford GT. It's the reason modern supercars have carbon tubs and multi-link rear suspensions and electronic stability control. The Cobra is the ghost in the room every time a chassis engineer argues with a powertrain engineer about what a platform can safely handle. And now, 6 decades later, its legacy costs you the legal right to drive one. The last car on this list is arguably the most tragic ban of all. The Tatra T87, designed by Hans Ledwinka and manufactured in Koprivnice, Czechoslovakia, from 1936 to 1950. This is a car that was so aerodynamically advanced, so mechanically revolutionary, and so far ahead of its time, that it influenced everything from the Volkswagen Beetle to the Porsche 911, and then it was systematically erased from automotive consciousness. The T87 featured a rear-mounted air-cooled 2,968 cc overhead valve V8 engine, producing 75 horsepower. That doesn't sound impressive until you understand the context. The body's drag coefficient was 0.36 in 1936. For reference, the average family sedan didn't achieve that number until the mid-1980s. Some didn't achieve it until the 2000s. Ledwinka achieved it with a full aerodynamic body, design featuring a central dorsal fin for directional stability, faired-in headlamps, a curved windshield, enclosed rear wheels, and a rounded, tapering tail that anticipated streamlining principles by 50 years. The car could cruise at over 100 miles per hour on the pre-war Autobahn network, consuming fuel at a rate that embarrassed vehicles with half its performance. The chassis was another Ledwinka masterpiece, a central backbone tube running the full length of the car, housing the driveshaft, and providing torsional rigidity from a single structural element. Suspension was independent at all four corners, using transverse leaf springs in front and swing axles at the rear. The interior was spacious enough for 6 passengers, with the engine tucked behind the rear seat, cooled by a belt-driven fan, drawing air through vents in the rear deck. But the T87 had a fatal flaw that its brilliance couldn't overcome. The rear engine, swing-axle rear suspension, created handling characteristics that were treacherous at the high speeds the car could so easily achieve. At highway velocities, any abrupt steering input would cause the rear to break traction violently and swap ends with almost no warning. During World War II, when German military officers seized T-87s from occupied Czechoslovakia as staff cars, attracted by their speed and luxury, they began dying in single-vehicle crashes at an alarming rate. The combination of high-speed capability, intoxicating smoothness, and sudden, unrecoverable oversteer was lethal in the hands of drivers who didn't understand rear-engine dynamics. There are credible accounts suggesting the T-87 killed more German officers during the occupation than certain organized resistance efforts. After the war, Tatra produced the T-87 in limited numbers before transitioning to newer designs, and it was never exported in meaningful quantities to Western markets. Today, surviving T-87s face a complex web of restrictions that amount to effective bans in most jurisdictions. They cannot meet any modern emissions standard. They have no safety equipment recognizable to modern regulators. In most EU countries, operating one requires historic vehicle exemptions, specialized insurance, and restricted use permits that effectively limit driving to organized rallies, exhibitions, and pre-approved routes. In the Czech Republic itself, daily road use requires navigating a bureaucratic process so restrictive that most owners simply don't bother. This was a car that achieved a 0.36 drag coefficient in 1936. That pioneered the backbone chassis. That proved rear-engine packaging could create a luxurious, high-speed touring car decades before Porsche refined the concept. Ferdinand Porsche himself studied Ledwinka's work so closely that Tatra sued Volkswagen for patent infringement, and eventually settled for significant sum after the war. The Beetle's rear-engine, air-cooled architecture, its backbone-influenced floor pan, its swing-axle rear suspension, all of it echoes what Ledwinka built first and built better in the T87. Now you can't drive it to get groceries. The most influential sedan of the 20th century sits behind glass, waiting for someone to understand what it actually was. That's the list. 10 vehicles that governments, regulators, and bureaucracies decided you shouldn't be allowed to drive. And in every single case, the car itself tells a story about engineering that was too ambitious, too uncompromising, or simply too far ahead of the regulatory framework designed to contain it. Here's what I want you to take away from this. The next time you're scrolling through listings, looking at another overpriced Ristamad or another Concours Queen that's never seen rain, stop. Ask yourself what's actually underneath the paint. Think about the Tatra's aerodynamic mastery when most cars looked like upright boxes. Think about the Z-1 packaging genuine sports car architecture into a vehicle the size of a large appliance. Think about the Trabant engineers who invented a new composite material because their government couldn't give them enough steel. Think about the Citroën 2 CV interconnected suspension, solving ride quality problems that modern engineers throw computers and sensors at. The cars that get banned are often the cars that pushed hardest against what was considered normal, possible, or acceptable, and the mechanical lessons embedded in them. The chassis dynamics, the material science, the powertrain layouts, the weight management, are lessons that no auction catalog, no showroom salesman, and no social media post can teach you. If this video changed how you think about what makes a car worth understanding, hit subscribe. This is a space for people who want to be smarter about machines, not just louder about owning them. And the next time someone tells you they really know cars, ask them what a backbone tube chassis is. Ask them what Duraplast was made from. Ask them how an interconnected suspension system works. Their answer will tell you everything you need to know about whether they understand engineering or just recognize logos. Stop scrolling through listings. Start looking for the engineering underneath them. That's where the real value has always been. And that's where it's waiting right now, for the people paying close enough attention to find it.